Hello students, in today's session we will start the discussion about how to execute the programs, what are the steps we have to follow in order to log in, and what are the syntax or what are the commands I can use in order to execute the program. Okay, so here the software what we are using is Network Simulator 2.34 version. So if you search in Google internet like NS2 all-in-one 2.34, the software is easily available. You can see the steps, they will give the complete steps also in Word file. You can take that, and before that you have to install Ubuntu 16.04 LTS, or you can go with the Ubuntu 18.04 LTS, install it first and then you install this NS2 all-in-one. So if your installation is completed in your system, computer system, then you can follow the steps what I am going to deal in today's session in order to execute all the part A NS2 program. Okay, so the first system is you have to log in. The first step is to log in through Ubuntu. Then restart the machine with the Ubuntu mode. Okay, like we have to select Ubuntu operating systems in order to work these network simulator programs. Then you have to create a directory. You have to select a directory, okay, with your user number. So for that, creating a directory, the command used is mkdir, make a directory with the user number. Then I have to change the terminal. I have to change the directory. I have to change the directory by giving the command as cd. Cd, the same folder name what you have given previous for make directory, same thing should be given. Okay, then coming to for part A, in order to open the editor window, the command used is gedit n1.tcl. okay, gedit space file name. I have given the file name as n1 dot with an extension tcl. Okay, for all the NS2 program, the extension is TCL because it is a tool commanding language, hence the extension should be same. Okay, then save the program and then type all your complete program. Okay, once the writing the complete program you have written, again at the end you have to save. So for all the programs you have to give one more, you have to write one more program with a name that is AWK script, extension with AWK. So we are linking that AWK script to my main program, hence I have to give one more command as gedit space n1 dot awk. The name of the AWK script may be anything, but this particular AWK script I am accessing in my main program. Okay, so once the program AWK script and TCL script is written, then you have to run the program. So to run the program, the command is ns space n1.tcl. Okay, so all these three commands you are supposed to give in terminal window. So how to open the terminal window? For opening the terminal window, to open the terminal window, the command used is control plus alt then T. Okay, you have to press control alt and then T. Okay, so similarly you can follow the same steps for part B programs also. So I will show you it once. So I am pressing control, I am holding alt and then T. Then my terminal window opens here. So here you can give the path make directory with some name, just xxx. Okay, just I am creating this in my home page. Then I have to change the path with that particular folder. So change the path, change the directory to xxx. Okay, so under this xxx I have to open a editor window. in order to write the program. So for that the command is gedit space n1.tcl, file name.tcl. So when you enter, you will be getting one window with the name. See here, so n1.tcl, that means in home, just I will show where is that folder exists. Okay, so when you go to home, here I have created one folder with the name xxx, where I have opened, I have to store my first program n1.tcl. this is the folder. Okay, so now similarly I need to write the program for awk. Here only, after writing the complete n1.tcl, you can give command as gedit space n1.awk. Okay, so similarly next, what is my command? You can give the command next time. After writing both the programs, I want to execute. So what are the steps I need to follow for execution? The first step is ns, okay, space file name is n1.tcl. okay, here you can give a symbol, another symbol known as ampersand. So ampersand symbol is used in order to view both the window parallelly. Okay, so this is the steps what you are supposed to follow in order to execute the program. Okay, now we will see what are the different procedure which we need to see in order to write the program. Okay, so in order to write the program, here we need to follow some set of steps how I can implement my program. Okay, so generally for all the programs, these steps are common. So for all the programs, first what we are supposed to do is create an instance for network simulator. Okay, I have to create a new object which belongs to my simulator too. Okay, then with respect to that, I have to create a trace file and then animator file. Then I have to enable a tracing and animation file also. Okay, so what is the syntax for each? I will tell you in next slide. So next, I have to create the node. Then for each node, create the duplex link. Then I have to create an agent of my transport layer. I have to give the agents over the node. I have to attach my agents over the node. That means if you go with the create a node, if you are telling create a node, that ensures that the lower 3 layer of my TCP IP protocol has been done, initiated. Next, I will be creating transport layer protocol. Then I need to attach those transport layer protocol over the node. Then I have to create a protocol or the traffic which is used for application layer. Then I have to attach all these application layer protocol to my transport layer. Then I need to provide a logical link or the connection between sender and the receiver. Then I have to provide some instances, some event I have to give in order to start and stop the program, depending upon whether you are using connection oriented protocol or connectionless protocol. Then at the end you can run your program. Okay, so these are the steps what we need to follow for all the programs. Along with that, depending upon the applications, something should be extra added. Okay, this is a basic. Additionally, you can add few more features. Okay, so now we will see what is the syntaxes what we need to follow in order to write the program. So as I said, first step is to create the simulator tool. So the syntax for that is set, that is a keyword, within this square bracket. In this complete NS2 cheat sheet, whatever is written within this brace, greater than or less than brace, that is user defined word. Okay, my sim. In place of my sim, you can write my ns, whatever it may be. Okay, the syntax is set name of my object and then within square bracket it is new simulator. So it is a case sensitive, somewhere we are writing capital, that you have to follow as it is. For example, set, here in place of this I have written my sim, the new simulator. So this is going to create a new simulator object. Okay, so then I have to create a tracing files and name file. Okay, so how to do that? The syntax for trace file is set name of the trace file. You can write complete trace file, or you can write tr file, or you can write trf also. It's depending upon the programmer. Then within square bracket open here trace file name dot tr and then space small w. Means after the program execution is done, at each interval of time the output should be written in this particular file. Similarly for out.tr or nam.tr, out.nam or out.tr. Okay. So next example is set tr file within square bracket open name of the my tr file out dot extension tr and then w. Okay. So similarly for trace file. Okay. Similarly for trace file also. So next I have to create a node. So how to create a node? What is the syntax for creating the node? The syntax is set within this name of the node should be given. Generally we will give the name of the node as n0, n1, n2, n3 so on. Then in the square bracket I will be telling for which simulator object these nodes belongs to, and that is nothing but my node. Okay. For example, set n0 within square bracket I am accessing of, means this n0 belongs to my sim, hence the dollar symbol is used in order to make a pointer to that object, the node. So similarly you can write how many nodes you want to declare. For all the nodes same syntax is used. Okay. So in order to create a duplex link, so to create a duplex link the general syntax is my object name first. I am accessing through my object, hence dollar $myNS. What I am creating? I am creating a duplex link, hence duplex hyphen link, all are in small letter. Then you should say from which node to which node you are creating the duplex link. n0 to n1, n1 to n2, n2 to n3. So like that some nodes, source node to destination node, the name of the node should be given. Then I need to give some parameter, a basic parameter of my duplex link which has been given through bandwidth and then delay, propagation delay. So these two should be mentioned followed with source node and the destination node. Then I have to say I am working with respect to which type of queue. So there are n number of queues are there, but generally we will be selecting drop tail queue. So in drop tail representation, please ensure that D is capital and T is capital. Okay. So drop tail. So for example, dollar $mySim duplex link, source node is n0 to n2, bandwidth is 2 MB, propagation delay is 10 millisecond and type of the queue is drop tail. Then after declaring the link, I need to say how this link is oriented. Okay. So for that the syntax is my object name, the duplex link, how, op means opposite, how it has been placed. Okay, how it is represented. Then between which node to which node, and then orientation. Okay, so here orientations I can give in terms of 4 method: right down, right, left down, left. Okay, right, down, up, left, down, left. Okay, or exactly left or exactly right. So totally 6 different alignment you can give for each program. Right down, right up, left down, left up, or only right and left. Okay. So then I have to give label for each node. Okay, because I need to differentiate which is my source node, which are the nodes are router, and which are the nodes are receiver. So what is the syntax for that? So dollar node number means name of the node, label is a keyword, and then within the square double quotes you have to say what is the name of the node. For example, $n0, for n0 I will be labeling it as a TCP source. Similarly, you can say n1 is a router, n2 is a receiver. Okay. Then after that I have to say what is the queue limit. I have declared the duplex link, I have declared the orientation, then node is also labeled. Then I need to say what is the queue limit for each node. Okay. The syntax for that is $mysim queue limit from source to destination, and what is the limit. So that is just a number 10, 40, 20, 50. You can give t also. As the queue limit increases, the number of the packet drop is also decreases. We can see in program 1 and 2. By changing the queue limit and the bandwidth, you can vary, or you can see how the packet drop is increasing or decreasing. Okay. So next is how to attach the UDP packets, or how to attach the TCP packet. Okay. So for both the syntax is same. If you follow any one in the similar way, you can go with the another. For UDP, we are calling it as UDP packet, or for FTP, it is TCP packet. Okay. So create and attach UDP agent over the nodes at the sender side. So how it is? Syntax is set my agent, name of the agent, then I will be calling it as new agent belongs to UDP. Then $myNS attach agent to the node, calling it as my agent. Okay. Then how I can write the statement by using the above syntax? Set UDP new agent slash UDP. So this UDP is attached to which node? I have taken it as N1. So new UDP is attached to N1. Okay. So now node N1 becomes the source with UDP protocol. Similarly, I can assign a TCP agent. Okay. So for TCP agent, set TCP is the name of the TCP. What I have written? New agent of type TCP. So I have declared the TCP agent, and this TCP agent is attached to some node. So which node? N0. So now I have attaching this particular TCP agent to N0 with this particular statement, which belongs to same object myNS or mysim. Please left to you. Okay. So now this is at the source. At the sender side, if my node is UDP, at the receiver side, that should be declared, the node should be declared as a null. And at the receiver side, at the sender side, if I am declaring some node has a TCP, at the receiver side, the receiver node becomes sync, or generally I will be calling it as sync, or specifically you can say TCP sync. So how to declare the node, a receiver node? So syntax is here. These two statement will set the agent at the receiver side. Similarly for TCP agent. One is TCP agent, another one is null agent. That is set null is a name belongs to new agent with this null. Here this N is capital. Okay. And another way, which node it is attached? One is for all the case, one is declaration, and second one is attach that to some node. Okay. Similarly here, declare the sync agent of TCP sync. Okay, declare the sync agent of TCP sync, then attach that sync to the particular node. So null is attached to N3, similarly sync is attached to the same node N3 depending upon the requirement. Okay. Next, generally now I have to provide a connection between sender and the receiver. How that logical connectivity can be given? So that is given through this particular statement. $NS connect at TCP to sync. TCP at the sender side, receiver side sync. Similarly, I have to connect for UDP to null. Okay, UDP to null. A logical connectivity should be given. Okay, so after that what I have to do? I have to provide an application layer protocol, that is I have to create a traffic. For that also, first create a traffic and then attach that particular traffic to that particular protocol. Since if you are selecting the protocol as a UDP, then the application traffic is nothing but CBR. So set CBR of new application of type traffic, which is denoted as CBR. Then I have to attach this CBR to where? UDP. You cannot connect this to TCP because this is my connectionless protocol and this is belongs to traffic protocols of UDP relevant. Okay, so CBR is connected to UDP. Now similarly for FTP is application protocol with respect to TCP transport layer agent. Okay, set FTP protocol, create it first, application layer, create it and then attach that agent to TCP. Okay, so this is a general syntax for creating all the 5 layers of TCP agent, TCP IP protocols, So next, in some of the programs you are supposed to create a LAN, wired LAN. So you should know the syntax how the LAN is created. So general syntax for LAN is $mysim make LAN, then this set of nodes of LAN, like how many number of nodes belongs to that particular LAN, everything should be written through $symbol. Then what is the bandwidth and what is the propagation delay you should say. Then the type of the LAN is just created between logical link type and which type of queue handling, always it is drop tape, and IEEE standard for this wired LAN is 802.3 and the dot 802.3, this point dot is represented in NS2 TCL script is by means of underscore. Okay, so you can see one example, $NS or you can say $mysim, then make a LAN between the node N5, N6, N7, N8, N9. For that LAN, these 5 nodes belongs to, and the bandwidth of that LAN is 1 MB and the propagation delay is 10 millisecond, which is of type logic link, and queue of type drop tape. Then in continuity, the IEEE standard for that is MAC 802.3, that is _3. Okay, so this is by this like accordingly you can declare how many LANs is required in your program. Okay, so next, in some of the programs you need to set some of the error model or some of the loss things you have to introduce, or some way you have to write what is the data error rate. Okay, so here for that also general syntax has been given. You can follow the same syntax in order to represent. Okay, so the type of the errors which occurs over a link between the LANs are error model. Okay, so here the error models are set error, a new error model. For each word, first letter is capital. Then the type of error model may be loss model. Further, error which should be introduced between node N4 to node N5, and here the rate I will be telling in terms of 0.5. So for the $error space, set the error rate at 0.50 or 0.001, 0.6. You can write anything less than 1. That is nothing but my error. Similarly, you can introduce a data rate also for your program. Okay. So this is about introducing the error and the loss rate, data rate in the program. So for all the programs, I need to say when I have to declare some of the events or some of the activities when my particular protocol should start sending the packets. Either it may be CBR packet or it may be TCP packets. Okay. So for the general command is my name of the object, at what time the particular transmission should start. So it is time 0.1. What to do? Which type of operation? $CBR start. Means CBR is starting its started sending the packets from source to the sender. So similarly in next $myNS at 1 FTP start. Start event has been given. So after some particular long duration, I have to give stop duration. Okay. So this is the event given for particular application, when to start and when to stop the program. So after that I have to finish. For that finish instruction should be given. The time for that finish instruction should be greater than this 4.5. Okay. Next, how to run? What is the command for giving the run instruction? For that, simulator object name, just you can say run. Okay. So this is a final run command for your instruction. So next here, few things you have to remember for executing the things. Okay. So that is very important is trace file format. So once you execute, the output will be seen by ways of two different files. One is an animator file and another one is trace file. Animator file will give you the pictorial representation that is accessed through nam space out.nam. Okay. When you execute this instruction, we will be accessing animator file. Just it will tell from which node to which node the packet is transmitted and what is the amount of packet transmitted and how the packets are dropped from the router or at the receiver side. But whenever you want to see the actual packet transmitted, how much, what is the size, from where to where the packet drop occurs. So all those things you can access through this trace file format. Okay. So this is general trace file format where the first data is event, second data represents the time, third represents from which node, and fourth is to which node it will go, what is the size of the packet and what is the type of the packet and then size. Then it represents some flag bit, fade and all. This is not required for time being. So if you remember only till this, it's enough in order to get the statistical result with respect to all type of programs. So now coming to this event, here we have four possible event type, R plus minus D. That corresponds to, first R represents receive at the output of the link, NQ, then DQ and drop packet. Okay. So drop packet, receive packet, NQ and DQ. The second field is time, means at what time the program is executed. Accordingly, you can access the particular source, what is the source node, what is the destination node, at that instant of time how much packet is transmitted. Then third instance and fourth instance, from which node to which node the event occurring, it will give you the details. Input node and then output node. The next is type of the packet. It may be CBR or it may be TCP. Then finally, if you want to see what is the packet size, so that can be accessed through this fifth field. 1, 2, 3, 4, fifth field, sixth field. Then sum of the flag rest. Okay. Yeah. This is a general representation of .tr file. So as I said, if you remember from here to here, this is enough. Rest of the flag and fit field and then other representation is just required as per the obligations. Okay. Okay students, today we will stop our discussion with only this introduction part. In next session I will start from first program according to the syllabus, and we will be dealing with the first program, creating a 4-node wired network and different variations by varying the bandwidth, by varying the queue sizes. We will see whether the drop packet is decreases or increases. We will see the variations. Okay. Thank you all.